1.4 takes a look at more rational expressions. So looking at, this says perform the operation and simplify. So rational expression, basically a fancy fraction. I have a polynomial in the numerator and another polynomial in the denominator. So for this guy to perform this division, my thought would be to go ahead and factor the numerator and denominator and see if I'm able to cancel anything. So let me set that up. We talked a little bit about factoring already. So in the numerator, let's see, adds to -3, multiplies to 18. So I'm thinking 6 and 3. Let's see, is that one negative? That would be y squared plus 3y minus 6y minus 18. Looks good. Okay, the denominator, I need that lead 2y squared. So I've got 2y and y. Then I need a 3 as my constant. So 3 and a 1. Let's see if that works. If it doesn't, I'll try reversing those. That'd be 2y squared plus 6y plus 1y is my 7y. So that looks good. Okay, now you see how I'm actually able to cancel this common factor. So here's my result, my reduced fraction. Okay, so I mean, here I have a multiplication of two of these rationals. So I would just multiply straight across, but rather than like FOIL this out, I'm really looking for a cancellation. So be careful. This is a sum of squares. Okay, so a sum of squares where I have the plus, those are prime. Those do not factor in the real numbers, okay? But we talked about the difference of squares, this one. That's the one I can factor nicely, t plus 3, t minus 3. Then let's see, so I can cancel that with that. Oh, and that with that too. So the only thing left in the numerator then would be a 1. And then I'd have my sum of squares. I can't do anything with that. Okay, what about a division? So that could also be written. Here's my dividend. That's divided by my divisor. So I could write that as a compound fraction as well. Make sure I copied everything down correctly. Excuse me. Okay. So if you remember how to divide fractions, you leave the top fraction the same. The bottom fraction flips. And then you have a multiplication. Now this is just like the first example, as in I'm multiplying straight across. Let me see if I can figure out the factors. 6, so 3 and 2. That multiply to 6 and add to 5. X squared minus 4 is my difference of squares. And then, is that minus 4 and plus 1? Looks like it. Great, so then any cancellation, that one, and that one, huh? So I'm left with x plus 3 in the numerator, and then x minus 2 times x plus 1 in the denominator. So I would leave it like that. I mean, if you want to do the FOIL, you can. It doesn't matter. Usually the factored form is nicer to work with. Oops. There we go. So let's see. When I'm adding or subtracting fractions, that's a little different. With those, I need an LCD. Least common denominator. Okay. So like if I do something off to the side here, if I have 5/3 and I want to add 1/4. What do I have to do? Well, I have to multiply here by 4/4 and here by 3/3, right? So then I have 20/12 plus 3/12 for a total of 23/12, okay? So I'd have to do the same thing with this guy. So let's see, I'd have to multiply the first fraction by x plus 2 top and bottom. So because I'm multiplying by the same thing top and bottom, I'm not actually changing the value of the expression because I'm actually just multiplying by 1. Okay, so I would go ahead and distribute that 3. So that'd be 3x plus 6. And then just leave that denominator factored. Go ahead and distribute the x. So that looks like x squared minus x. Leave the denominator factored because the numerator is where we're going to have to do our combining. Okay, so let's see, we have 3x plus 6. Now we have a common denominator now. So we go ahead and combine those as one fraction all over that denominator. So let's see, I'll combine the like terms. That'll be x squared plus 2x's plus a 6. And then we have to see if that trinomial in the numerator factors. So my numbers, let's see, they'd have to add up to 2 and multiply to 6. So factors of 6, 6 and 1 and 3 and 2. So I don't think any combination of those is going to give me a sum of 2. So that numerator is actually prime, as in it can't be factored. So in that case, this would be my final answer. And then like I said, I mean, if you want to, you can FOIL the bottom, but I don't see any reason that you would. More work. If you want to, though. Okay. What's next? All right, so same thing. A little more complicated. Let's see. So, well, I have to figure out what the LCD is. So I'd probably factor that GCF out of the denominator there. Because that way when I'm looking at these, I can tell, look, here's x minus 1. This guy already has both those factors. So my LCD would just be that x times x minus 1. So the first fraction, it's just missing the x minus 1 factor. The second fraction is just missing the x factor. So I distribute that 2. Distribute that, well, multiply the 3 and the x, and then I have minus 4. Now, I can go ahead and write this all over one fraction because all of this has that common denominator now. Combine the like terms in the numerator. And then I guess that's it. Here we have these compound or complex fractions. So these are interesting. So this is when you have like these mini fractions within this bigger overall fraction. So I know we kind of did some examples like this already. So what you'd do here is you'd still look for the LCD, but I'm looking for the LCD like of the smaller fractions. Like look, what would I have to do if I were going to combine in the numerator? I'd have to multiply this by y over y, right? So I'd need a y. In the denominator, let's say I'd have to multiply this by x over x. So my LCD is that xy. But instead of actually doing the numerator and denominator separately, what I'm going to do is, I think I did this in the last section, I'm going to take that LCD and I'm going to multiply by that LCD top and bottom, because look at what happens. So when I distribute that, the y cancels. I have x times x, that's x squared. Here there's nothing to cancel, so I have plus 1xy. But I get rid of the small fraction. Look at the denominator. It'd be xy. Here the x would cancel, so I'd be left with minus y times y minus y squared. So that works out nicely. What is the GCF, the greatest common factor in the numerator? I can take out an x, right? And in the denominator, I can take out a y. Just to see if anything's going to cancel, but I don't think so. Look like that. And I think that's the last one. Same idea. So look, if I were going to combine in the numerator and denominator separately, what would I do? I mean, I'd multiply this by x plus 4, multiply this by x plus 4. That's the long way. So instead, I'm going to say, okay, what's my LCD? X plus 4. And then what I'm going to do is, I'm going to take that x plus 4, I'm going to multiply the whole fraction, top and bottom. Okay, so that 5, nothing to cancel. It stays attached to the x plus 4. When I distribute here, I cancel that x plus 4, right? That's the idea, so I'm just left with a 3. The denominator, that 2 stays attached to x plus 4. Here I can cancel. Just left with minus 5. Go ahead and distribute. So 5x plus 23, 2x plus 3. So that trick's going to come up a lot throughout the course. We encounter a lot of those complex or compound fractions.